Alright, section 2.2, solving combined inequalities. We're going to have two objectives here. The first, to define and discuss the terms conjunction and disjunction. The second, to solve combined inequalities as conjunctions or disjunctions. When we think about these in the next section or two, we want to think about the fact that combined inequalities are really like when we have limitations on different things. So if you had a limited amount of a resource, a min and a max value, you use a combined inequality to represent that. First, we need to define them. A conjunction is the statement x is greater than a and x is less than b. Well, it can simply be read as a is less than x, which is also less than b, or in layman's terms, x is between a and b. If it was less than or equal to, then x would be between a and b, but it could also be a or b. But that wasn't the case as to what we had. So for now, it's between a and b exclusively, meaning not including the endpoints. Next, for disjunction, we want to think about the fact that a disjunction is separating the statement. So it's either greater than a or it's less than b. It's not both of them. This was an and statement, meaning both of these statements are true. Whereas here, one is true or the other is true. The first of the two with the conjunction is a good analogy for a Venn diagram. If you think about a Venn diagram and you talk about the amount of people that play soccer in a high school and say it's 30, and the amount of people that play baseball and it's about 18, and then you say, well, how many play both baseball and soccer? And there's 7. That overlap of those two different things is like an overlap of two sets. That's what this is here. A conjunction is an overlap of two sets. X is greater than A and it's less than B. You play baseball and you play soccer. Okay, so keep that in mind when we go to this next problem. The overlap of two sets, it helps with our solution. Alright, let's take a look at example 1 here. We've clearly got a combined inequality and it happens to be a conjunction because we can see that it's written this way. Okay, with the variable term in the middle and the boundaries on the end. But now we have this plus 3 and there's a negative sign. So let's think about this. Here's how I want you to treat this. Treat this like one problem and treat this like the other problem. It's an and statement, so break it up that way. So in red we have negative 2 less than or equal to negative x plus 3. And here on the right hand side we have negative x plus 3 less than 4. So we're going to combine this like an and statement, but at the end we're going to wait to do that. So here let's solve. Let's subtract 3, we get negative 5 less than or equal to negative x. Divide by negative 1 means flip the sign. X is less than or equal to 5. Again, read it this way. X is less than or equal to 5. Then on the right hand side, we're going to subtract the 3, giving us negative x less than 1. Divide by negative 1, but flip the sign, giving us x is greater than negative 1. Now this is an and statement, as we said a moment ago. So we need to look at the overlap of two sets. So the easiest way to do that here is to graph these two together and look to see where they overlap. And it's pretty obvious once you do it. On a number line here, we'll start with our 5 and our negative 1. We're told that x is less than or equal to 5. So we start with a closed circle here in red, and we shade to the left everything. Then we go to the next part that says x is greater than negative 1, not greater than or equal to, so that's going to be an open circle, but it's greater than, so we shade to the right. And what I'm going to do now in blue here is highlight the areas where they overlap, and it's clearly from here to here. It's where both sets exist. Here we're missing the bottom set. Here we're missing the top set, but they both exist between negative 1 and 5. So that means that's our solution, is the overlap of the two sets. The way that's written is just continue to, or copy the endpoints you were given here. So since we have these two endpoints, here's what we end up getting. So in blue is our solution here. How do I write this as an inequality and solution set form? Let's take a look. I want to start at negative 1 and go to 5, but I want to remember that my answer does not include negative 1. So it's negative 1 less than x less than or equal to 5. This could also be thought of that x is between negative 1 and 5, including 5. You can write this in interval notation, and you're going to see that when you get to pre-calc. So I'll give you a little preview of it. Interval notation simply means we're going to use brackets or parentheses. And whenever you have a less than sign or a greater than sign without the equal to, you're going to use a parentheses. So in interval notation, it would look like this. From -1 to 5, including 5. So the bracket is what's representing this little equal to symbol here. I'm making a bracket because of that. It means include the 5. Or the bracket is like the closed-in circle, and the parentheses is the open circle. Some people also graph their solution sets like this, by the way. Using the interval notation brackets on the number line. So let's take a look at example 2 here. We clearly have a disjunction because the word or is there in the problem. So we can start by just solving these separately. The left-hand side, subtract 7 from both sides. You're going to get C is less than -3. On the right-hand side, we're going to subtract 7 also. But here we're going to get -C less than -6. Dividing by -1, C is greater than 6. So C is greater than 6, or C is less than -3. On a number line, here is 6, everything greater than 6. Here's -3, everything less than -3. And we can clearly see there's no overlap because it's one or the other. Hence the word or in our answer. So in solution set form, it would be and this one's kind of interesting to look at in interval notation because really it starts at negative infinity and it goes all the way to positive infinity. So here's how the notation is written for this. You start at negative infinity and you use a parenthesis to indicate that negative infinity is not included in the answer. It's not like a closed circle, it's like an open circle because you can't get to negative infinity. And you get to -3, but you don't include -3. And then you want to say or, there's the or symbol in interval notation, and then you go from 6 all the way to positive infinity. Again, the interval notation I'm showing you, you're not going to get tested on this in this year, but I want you to see it so you're used to it. So this would mean from negative infinity all the way to -3. So all the way out here at negative infinity to here, take a jump or skip or from 6 all the way to infinity. If this had been a closed circle, these would be brackets. But again, these would always be parentheses at negative and positive infinity. Alright, example 3. To do this one on the left-hand side, I would get rid of the negative in the front by dividing by -1 at first. But that means we're going to have to switch the sign right away. So we're going to start by just putting k minus 1, and we'll put a -4, but instead of greater than, put a less than. And the same thing over here. Start with 1 minus k, and then instead of a less than, put a greater than, and that's also a -4. Now for this problem, we're going to notice here, let's solve the left-hand side one. We're going to have k is less than -3, and on the right-hand side, when we subtract it, we're going to have negative k is greater than -5. When dividing that, it becomes k is less than 5. So k is less than -3, and k is less than 5. And at this point, a lot of people get stuck here, and they don't know what to do, because they're both less than. It's not like an interval with a conjunction, so you don't have to worry about like just a middle part, but you still have to think about overlap of two sets, because it's an AND statement. So for all AND statements, start by graphing them. And if you have trouble, just look at the graph always. Here we have -3, here we have 5. So we have everything less than -3 and everything less than +5. Well, what's everything that's in both sets? That's everything in both sets is from here over. And it's not including the -3, because -3 is not in the first answer. -3 is not in this answer. So it's an open circle. So your answer happens to just be k is less than -3. This is missing right here. It's missing. It's not in both sets, so we cannot include this region. So only from -3 to the left is part of our answer. So in set notation, our answer would look like the following. Alright, example 4 here. What we're going to notice on the right-hand side is we have decimals. Don't let that confuse you at all. Solve the left side first. So let's subtract 1. We'll get 2f less than -10. Divide by 2. We'll get f is less than -5. On the right-hand side, though, multiply everything by 10 to start the problem, to get rid of the decimals. So we'll have just 1f plus 5 is greater than 0, or f is greater than or equal to -5. So either f is less than -5 or it's greater than or equal to -5. Well, that's kind of interesting. It's an or statement, but it's kind of an interesting one. Put -5 here. Everything less than -5 looks like that. But everything bigger than or equal to negative 5 looks like this. It means color it in greater than or equal to negative 5. So it turns out that it's all real numbers. In this problem, you have all the solutions to the left of negative 5, and then negative 5 and all the solutions to the right. And this is easy to see because when you think about a line, remember that it's an infinite amount of points. So this point is just part of the line. If you have closed circles all next to each other, that's what a line is defined as. So here it's just all real numbers. So f is in the set of all real numbers. So for example 5, we have x minus 7 greater than 4 and x plus 2 less than 4. Well, let's take a look here. It's a very simple one, but we're going to see there's probably going to be something intriguing here. Add 7 to both sides, we get x is greater than 11. And over here, subtract 2, we get x is less than 2. Well, is x ever greater than 11 and less than 2? Clearly it's not. And we can check and see that on a number line. When it's greater than 11, it means it's everything to the right of 11, and less than 2 is everything here. So it looks like a disjunction, but it says and. There's no overlap of these two sets anywhere. They don't cross each other anywhere. So there's no solution to this problem, or it's simply an empty set. And here's your homework for section 2.2.